Okay, so far, this is your notes. Shapes and Designs 1.1, sorting and sketching polygons. Okay, I have a short day today, or we have a short day today. I'm not here today, so I'm going to write down your notes here for you guys to copy along with. Okay, so um, let's see. On the second page, so behind what we did last class, I have this page here. It looks like this. I'm going to turn the screen a little bit so you can see the whole thing. Okay, I'm going to start right in the center. Okay, I'm going to start right, no, maybe not exactly in the center, but maybe a little bit closer to the top. Okay, so I'm going to start off with the word polygons here in the center. We're going to make a mind map of ideas. Okay, so a little small, not too much, not too big because it's going to take up a lot of space. Okay, we are going to end up making something that looks like this. Okay, we're going to put all this stuff here. So I'm going to start with polygons closer to the middle top, maybe a little higher than it is right now. Okay, so polygons, and polygons, I'm going to make a brief definition. Okay, let me zoom in a little bit. Polygons are closed, straight. So closed, straight, no curves. Flat, this is the one that we forgot to write down. Multi-sided figure. Multi-sided shape. Okay. Polygons are very specifically flat. They are not three-dimensional. I'm going to draw a very generic polygon here. And what I mean by generic is it doesn't have any defining features to it. I didn't want like a parallelogram. I didn't want right angles. I just picked some random shape that we have here. Okay, so very generic shape. Nothing very particular about it. Okay, so it looks kind of like that. You can pick whatever shape you want. I just picked that shape. All right. I'm going to do triangles off to the side. And I'm going to try and do this a little quickly. And I'm going to do this in blue, dark blue. Okay, so these are my triangles over here. And I'm going to define triangles two different ways, by side length and by shape. Sorry, by side length and by angles. So the first one I'm going to do is by side length. Okay, so these are going to be, the types that I have are going to be in decreasing specificity is going to be equilateral, and then we have isosceles, and I've been working on spelling this right. Isosceles, and then we have scalene. Okay, those are the three types that we have. We'll write an example, and then we will draw an example. Okay, all sides are equal length, or all sides are equal length. So now my triangle might not be a perfect isosceles, equilateral triangle, okay? But I'm going to show you the markings that represent equilateral, okay? If I draw markings that look like this, these lines or these dashes represent that those side lengths are equal. So I'm going to say dashes on sides represent equal lengths. Okay, and I'll draw the example that we have here. Okay, and I'll point them out. Okay, so if I have these marks here, I'm specifically talking about these items. So these sides are equal. Okay, all equal side lengths. Okay. All right, keep going. Oh wait, one last thing. In the shape set, example A is an example of what a nice equilateral triangle looks like. An isosceles triangle will have two sides that are equal length. Okay. Now, if two sides that are equal length, it will look something like this. Okay. And example in your shape set would be example letter P. And again, if I have dashes, those represent two pieces that are equal to each other. So those two side lengths are equal. Okay, those are two equal side lengths. Another key feature is they are symmetrical. Okay, that comes with the two equal side lengths, but it isn't a requirement, but it becomes a requirement. Scaling is no equal side lengths. Okay, I know it's a little bit tight here. I know you guys can't move yours down, so hopefully yours had enough space, unlike me. Okay, and I'm gonna draw a really quick example, something that looks like, there you go. All my side lengths are different, so I'll put 1, 2, 3, and it represents that none of them are equal to each other. Okay, an example like this one on your shape set would be something like letter I, shape I. Okay, all right. Down here, we're gonna define triangles, okay, by angle, and the three different angle types that we have. Okay, the three different angle types we have are acute triangles, right triangles, and obtuse triangles. Okay, so there are acute, right, and obtuse. Okay, so those are the three types that we have for triangles defined by angle. Okay. So acute has 3 angles less than 90 degrees. Okay, all of them are less than 90 degrees. Okay, again, you can use triangle A as an example. It could be an equilateral triangle because all of the triangles are going to be 60 degrees. They're all going to be less than 90. Okay, so that's less than 90, less than 90, less than 90. Okay, a right triangle is a triangle with one right angle. One right angle. Okay. Let's scoot this down a little bit. One right angle, and I'm going to draw a right triangle. There we go. And I'm going to define my right angle with a square. Okay, so I'm going to say 90 degrees is equal to a right angle. Okay, 90 degrees is drawn or displayed like with a square. Okay, maybe I should, a right angle can be drawn using that. Okay, if there's a square in the angle, that means it's 90 degrees. Okay, so that's a right triangle. Okay, all right, obtuse. Obtuse is going to be one angle greater than 90 degrees. Okay, so I'll draw my triangle. It's kind of like that scaling triangle I had earlier, but it doesn't have to be. You can have an isosceles obtuse triangle. Okay, this one is more than 90 degrees. Okay, this is more than 90, greater than 90 degrees. Good. There we go. So I've got 6 triangles so far. Okay, looks like this. Oh, sorry. There we go. That's better. Looks like this. I got 6 triangles. Okay. Now we're gonna go to this side and we're gonna draw quadrilaterals, and quadrilaterals take quite a bit of space. Okay. Oops, sorry. All right, so quadrilaterals. I'm gonna start off here, and they take a lot of space. So, quadrilaterals. Okay, quadrilaterals. And again, I'm gonna zoom in a little bit so we can see what it looks like. Four-sided figures. Okay, our four-sided figures. I'm gonna draw some generic shapes because again, I don't want to define anything specific. Okay. You can have something that looks like this. It's got four straight lines. All of them meet at an angle. It's closed shape. It's a four-sided figure. Okay, quadrilateral. Okay, quadrilaterals can be broken down into many different types, but we're going to start off with a trapezoid. Okay, I'm going to put my trapezoid over here. Try to use as much space as possible. Trapezoid. Okay, my trapezoids are going to have one pair of parallel lines. And that's a little bit large, so I'm going to shrink that down a little bit. So if you can keep your writing small as possible, that'd be great. Okay, one pair of parallel lines, and I'm going to draw an example of that. Okay, there are different types. Okay, this is a trapezoid. Okay, now I'm drawing three different types of trapezoids. So there's one type. Okay, and I'm going to put the markings on here because again, we need to learn what these markings represent. If I have arrows across lines, that means that they're parallel. Okay, so off to the side, I'll write this over here. I'm going to draw two lines. Okay, and they don't have to be there. Maybe they're going to put here and here. They're easier to see. 1, 2, and if I have arrows, okay, it means they're parallel. Lines with same number of arrows, means parallel. Okay, I'm talking specifically about these. So these two lines are parallel to each other. Okay. Again, pause the video if you need to, and then continue as it goes on. So that's a trapezoid. It's four-sided figures. I have one pair of parallel lines. Okay, you can also have a trapezoid that looks like this. Okay, and this is a right trapezoid. Okay, because it has two right angles. Call this a right trapezoid. Okay, and you can also have a isosceles trapezoid, which is probably the most common ones that you see people draw. You see right trapezoids that look like this. Sorry, isosceles trapezoids, where it is symmetrical. Okay, it looks like if you continue this, it would make an isosceles triangle. Right, that's what an isosceles trapezoid looks like. Okay, so this one is isosceles. Isosceles trapezoid. All right. Okay. Well, I took up a lot of space. Over here to the right, I'm going to drop down and I'm going to make a group called rhombus. Okay. The plural for rhombus is rhombi. Okay. Rhombuses have four equal. Oh, my handwriting is really bad there. It's still really bad. Equal length sides. So all the sides are going to be equal length. Okay, a lot of people refer to this as diamonds. Okay, so this side, this side, this side, and this side. They're all the same length. Okay, that's all it needs to be. So again, I'm going to define these with lines. So this side, this side, this side, and this side, those dashes mean that they're all the same length. Okay, rhombuses are often referred to as diamonds. Can't spell. Diamonds? Wow. D-I-N. Diamonds. Diamonds. Okay. All right. I'm going to leave my rhombus there, and I'm going to go down my trapezoid pathway. And instead of one parallel line, I'm going to keep going and increase it and call them parallelograms. Parallelograms. And they have 2 pairs of parallel lines. So 2 pairs of parallel lines. Okay, let's put this over a little bit. So if you write yours incorrectly, just highlight them and drag them and move them around. It's really easy. Okay, parallelograms. Okay, 2 pairs of parallel lines, and an example would look something like this. Good. All right, parallelogram. There we go. Here's my markings so that you know what they look like. Okay, this one and is parallel to this one, and this one, the left side is parallel to the right side. They're all also equal length, and that's the only way it would work. If any of them were, if opposite sides were not equal length, then it would not. Then the other 2 could not be parallel. All right, parallelograms. Okay, and from parallelograms, we are going to let's do some examples from your shape set. Parallelogram could look something like, parallelograms would include things like L, M, N. Those are all parallelograms, and also the rectangles. But for now, we'll just talk about parallelograms. So I'm just going to put example N here. Oops, wrong. Shape N. Okay, from parallelograms, I'm going to make rectangles. Okay, rectangles are going to be parallelograms. Parallelograms. That means they have all the requirements of parallelograms, but they also have one thing else in common. Plus, I'll make it look like a math equation. Rectangles are parallelograms plus 4 equal angles. I'm going to put this in parentheses, 90 degrees. Okay, so parallelograms plus 4 equal angles. That represents what a parallelogram is. Okay, let's scoot this over a little bit. There we go. So if I add those 2 ideas together, I end up with a rectangle. Awesome. So here's what a rectangle looks like. Okay, and I'm going to put all the markings that I do on a parallelogram plus those 4 equal 90-degree angles. Okay, so these 2 are parallel to each other. The left and the right are parallel to each other, and 90 degrees. Again, we do that with a square. Okay, that's a square. Right, now I kind of have this open space here because if I combine all of these ideas, well, all of everything that I have here, but it's mostly just the ones at the end. Okay, if I combine parallel rectangles, okay, there's my rectangles, and I combine rhombus that has all the same side lengths, okay, I end up with a square. Okay. Now, even though a square is one of the more basic shapes, it's the most specific shape. Okay, 4 equal side lengths, parallel lines, and 4 equal 90-degree angles. Okay, so I'm just going to put rhombus plus rectangle, okay, because that's what it is, okay. It's also a regular polygon. Okay. Now I'm going to put this inside a square. Okay, squares are very unique to math. We use them to represent values that are squared, and they have a certain length value because of it. So 1, 2, 3, 4, 5, 6, 7 spaces. 1, 2, 3, 4, 5, 6, 7 spaces. Okay, let me scoot these over a little bit so. There we go. And then, so that way we can use this as an example. Again, parallel lines, okay, and 90-degree angles. Now, I could mark these like this with a single dash so that they're all equal, but it gets a little crowded in there. So, you know, there's a lot of things going on with that idea. Okay, so I'm going to turn this to the side so you can see the whole thing. You'll see a little bit of the other stuff too. Okay, so it should look something like that. You have all of them there. Okay, I was going to put hexagon, pentagon, etc., but I think that's a little bit excessive. Okay, you should have all these items. It will be posted online so you can see them all. Okay, your homework tonight is going to be a quizzes game. Okay, you don't have to write this down, but I'm going to put up here homework quizzes game. Quizzes game. Okay, so if you don't have access to the internet at home, now's a great time. Go to the library first. Okay, go to the library first so that way you can see, you can get your game done. Okay, have this filled out. I'll check your homework when I get back. Have a good weekend, guys.